In part 5 of the SKU-T module, we're going to learn how to make good use of this particular chart to see if a cloud will form, at what level it will form, the base of the cloud, the bottom of the cloud, and how high the cloud will rise. To do this, we have to compare the actual temperature of the atmosphere at different levels, which you see here with the red line. Again, this particular line was developed by a balloon being launched upward into the atmosphere and temperatures being taken at various levels. Now, to do this, we need to start off and take an air parcel. So we're talking about two separate processes here, the environmental temperature, the temperature of the atmosphere, and looking at the temperature of a single air parcel. Again, we talked about this in the stability video. If you have any questions about that, I encourage you to go back and review that particular module. What I'm going to do is I'm going to take an air parcel at the surface of the Earth, and I'm going to choose the temperature of the air parcel as the same temperature of the environmental temperature at the surface. So the environmental temperature is, it looks like about 15 or 14, somewhere in that area. Keep in mind we're looking at temperature because it's going off to the right. We're comparing the two isotherms, the 10 degree, the 20 degree, and this is about halfway between 10 and 20, so I'll call it 15. So I start off with an air parcel, a dry air parcel, and we know from the chapter on the dry adiabatic lapse rate that a dry air parcel decreases in temperature 10 degrees Celsius per every kilometer. Okay, 10 degrees Celsius per kilometer. So what I'm going to do is I'm going to follow the dry adiabats, that's these particular lines, the gold lines in this example, and I'm going to move the air parcel parallel to the dry adiabat. And I'll move it up a little ways. I'll move it up to about 850. Notice this line here, the air parcel is following parallel to the dry adiabat. I'm choosing this particular adiabat because it's closest to the air parcel. So the air parcel is moving up parallel. Now, I'm also going to take the dew point temperature at the surface, and I'm going to take the dew point portion of that air parcel and move it parallel to the saturation mixing ratio lines, which is the dashed green lines. So I'll take that, and I'll move it parallel to the nearest saturation vapor pressure, saturation mixing ratio line, until it intersects the dry air parcel. Notice it intersects the dry air parcel at about 900 millibars. So I took the temperature dew point, followed parallel to the saturation mixing ratio line, and where it intersects with my dry air parcel is the base of the cloud. It's at that point that the air parcel hits the saturation vapor pressure curve that we learned about back in chapter 4 when we talked about atmospheric moisture. This is actually the location of the bottom of the cloud. Now, since the air parcel is now considered moist, instead of following the dry adiabats, which is this line here, the air parcel, now that it is completely saturated, we're now going to follow the saturated adiabatic line, or we're going to follow parallel to it. Recall that the saturated adiabatic line, the saturated adiabats in this particular example, is the purple line. So I'm going to now take my air parcel disregard that, it shouldn't be there. I'm going to take my dry air parcel here and I'm going to move it parallel and get this to work here. I'm going to draw it parallel to my saturated adiabat. We'll pick up here in the next chapter, or in the next module.